Okay, so Aaron, I just want to have you point out the microphones, the 3 microphones. 3 different colors. They're the same microphone, right? But they're just color-coded for ease of channel identification. And then the protective tubes. And then the pre-prepared cable, which is 15 meters for each loop. Gives us a 20-25 meter aperture array. And finally the data logger, the data cube, which is powered off of D cells. The data cube in this wet environment goes inside that bag. Okay, so we're here at Reventador Volcano, which is in the clouds over there, and what I want to show you is how to install or not deinstall a mini infrasound array. Mini infrasound arrays, we've been using these for a long time at volcanoes and for recording other geophysical sources, and we've gotten them to a point where they're easy to install and to record data. So what I'm showing you right here is a commercial data logger that is designed for seismic instrumentation. It's a 3-channel seismic data logger, but we use it for 3 channels of infrasound recordings. The data cube is connected to a GPS right now, so that means acquisition is on, and we've been recording for 48 hours here at this volcano. All right, so now I'm going to show you what each of the sensors looks like. This 3-channel splitter that comes into the data logger goes out to 3 separated microphones. And I've shown them as different colors, red, green, and blue, which correspond to channels 1, 2, and 3. And each of these microphones have already been surveyed, so I know their precise location with respect to the data logger. And the data logger has its own GPS location. Okay, and we need those precise locations measured with a tape measure and a compass in order to properly do beamforming for our infrasound array. All right, so we'll visit one of these channels right now, and suffice to say, all 3 microphones are identical. We'll go visit channel 1, which is towards the volcano right now. And I've built these cables such that each one is 15 meters in length. And it turns out that's a pretty good aperture for an array to record energy between 1 and 10 hertz, which is what a lot of volcanoes tend to produce. So here's the microphone channel 1. And again, we installed these 2 days ago, and right now all I'm doing is taking the array apart, and I want to bring it home. So inside this PVC tube is the microphone itself, which is being powered off of a 9-volt battery for a short deployment. Effectively, this is a battery that will power this thing for up to 10 days, and the data logger is powered off of internal alkaline batteries for about 10 days as well. Okay, so we protect these sensors by putting them in a PVC tube. So this is an infraBSU version 2 infrasonic microphone with a flat response between 10 seconds and whatever the Nyquist frequency is. And in this case, we're recording at 400 hertz, so the Nyquist is 200 hertz. Okay, in order to install this thing in the field, it's fairly straightforward. These tubes, this one's filled with a little bit of dirt, provide the protection, and we can go ahead and insert this cable, which we made ahead of time, into one of these holes. Go with the upper hole, slide it into the tube, connect the 4-pin connector here, seat it in the PVC, and then the last thing we'll do is power it up. Now this is a short deployment, and we've used alkaline batteries to power up each and every microphone at the microphone. But for long-term deployments, we'll actually put power in through this cable. And it's not necessary if you're, again, deploying for less than 10 days. So now we have a protected microphone, which is especially important here at Reventador, because at Reventador we have a lot of moisture and a lot of rain. And all I want to do is effectively seat it down such that it won't topple over, and have it down close to the ground layer, because this is where the wind noise is lessened. And this is an ideal situation for deploying infrasound because we are in a vegetated area, and even though there might be some wind up above, this vegetation just cuts down on that wind and protects the pressure fluctuations such that most of what we're recording here is going to be signal from our volcano. Okay, so in the event that the microphone is not responding as expected, in other words, maybe we're not seeing the infrasound waveform on this channel that we're seeing on other sensors, we might suspect that the capillary tube needs to be replaced. And this happens very infrequently, but there are situations in which that capillary tube can be compromised. All you need to do is open up this volume, protective volume, pull out the old capillary tube, insert the new one, make sure it's snug, and then use the Phillips head screws to close it up again. Now this particular capillary tube is about a 10-second corner or 0.1 hertz corner, and we can also swap that out for a different corner frequency capillary tube.